All right, we're just waiting up here a little bit, waiting for everyone to check in. Give it a few seconds. I don't know how this sounds. So how noisy is my machine? Can you guys all hear my machine? I'm using a new microphone. I'm not sure how noisy my machine is. I've got this laptop that's working way over time. I'm not quite sure how just noisy it is. All right, well, let's get the show on the road. All right. Hey, world. Greetings, Houdini users from around the world. It is 3 o'clock. It's Friday, which means it is time for another episode of Houdini Secrets Live. My name is Chris, and I will be your host for today's lecture. Now, if you remember, we've been talking about Houdini Dynamics for the last few weeks, and this is quite a large topic, and we're going to be continuing working on this until somebody requests otherwise, because this is a big gap in my knowledge. And although while I know the basics and the overall broad strokes of Houdini Dynamics, I never really did a deep dive into the modern incarnation of Houdini Dynamics. And so this is as much of a learning experience for me as it is for you, and I'm more than happy to share it and teach it to you, because when I share it and teach it, it helps me understand it all the more better. So thank you very much for working with me, and thank you very much for contributing and making me a better educator. And so one of the things while working on the rigid body dynamics and working with the forces and working with the grains is something called Gle Constraints and rigid body dynamics glue. And I never really found any kind of specific information. I look for it on the documentation, and it really never made much sense. So I said, okay, we're going to have to give a class on this in order to figure out what it is. So I went and we said, okay, this lecture is going to be devoted to nothing but focusing on Gle constraints and on other constraint networks. And so I realized that Gle constraints is probably one of the most basics of all the forces. And so when I was looking around, I actually came upon a lecture given by Bubble Pins that really geared down and then went into the fundamentals of explaining what exactly Gle constraints exactly were. And this answered a lot of my questions, and it presented a lot more questions that I had, and I sought out to explore the answers to my problems by actually getting my hands dirty and playing around. So anyway, hats off to Bubble Pins. Thank you very much for providing a lot of the motivation and spirit for this lecture, and you'll see a lot of similarities between your lecture and mine. But today, what we're going to be going over is very simple destruction, and give a fundamental introduction into Gle constraints. And I'm going to be going over, this is also going over DOP network construction, because all of forces that we were talking about a few weeks ago manifest themselves in network construction, and it's important to understand what force networks are and how and what are the advantages of controlling them. And we're going to be dealing with this, and we're going to be going over effective debug strategies for dealing with how to procedurally go about editing and modifying your simulations in order to best understand it. And I see a lot of similarities to other things like lighting, and there's a lot of really good tidbits in here. And then we're going to finally export this simulation to Engine, because ultimately I'm focusing on real-time demonstrations here. And so this is not just Houdini for offline. Unless this has some kind of real-time application, I'm not really going to focus too much on it. So yes, we will be exporting to Engine on this. All right, so let's get started with the actual demonstration portion. All right, and let me get things going here, and here we go. All right, those are my notes, and I wanted to make sure that those were there. And okay, great. And we're all up to speed. So we're going to go ahead. I'm just going to go get my lecture started, and I'm going to create basically a simple wall, and we're going to break apart this wall and show you how it fundamentally is held together with glue constraints. I'm going to throw down some geometry, and I'm going to call this fractured wall. I'm going to drop into here, and then I'm going to throw down a box. And in this box, we're just going to go ahead and scale it. Well, the first thing I want to do is I want to position it so that it's always sitting above the origin in the y-axis. So I'm going to multiply the y center by 0.5 times ch, and then in that we're going to do size y and close parentheses on that, and boom. And so now you see there's a little trick there. So my object is always going to be above the y origin no matter what. And so we're going to go ahead and just basically size this up into a good size. We're going to make it 8 by 4 by, about 0.7. All right, so there's our wall, and it is ready to rock and roll. And so what we're going to do is we're going to bust this apart. Now, if you were to go ahead and use the model, and if you were to go into the shatter thing, it's a lot of the same objects, but we're going to explain exactly what's going on here and why. So I'm going to drop in an ISO offset. And the ISO offset transforms this into a volume. And so right now we see it as a fog volume, but if we wanted to turn this into a signed distance field, there you can see what the signed distance field looks like onto it. But for our purposes, we don't need to see what a signed distance field is. We can keep this as a fog volume. Because then what we're going to do here is we're going to drop in a scatter node. And what the scatter node is going to do, it's going to put in 100 some points. Now, I'm going to turn this on so it becomes a little bit more visible. And actually, I'm going to see if I can make my background a little bit darker so it becomes a little bit more visual. And maybe you can see that a little bit better. Now, 1,000 points is a little extreme. We could do 1,000 points, but I'm going to just stick with 100 points because it's a little easier to see for my future demonstration. All right, we've got the ISO offset, but really what we wanted to do was to scatter 100 points within the volume of the box rather than just have it randomly placed. So I'm going to follow up by dropping in a Voronoi fracture. Now, Voronoi is an algorithm used for doing decomposition in such a way that it creates polygonal data in between adjacent points such that the edges of the polygons are equidistant in between the 2 points. Well, that's a little bit, it's a lot easier to see than it is to describe. But I'm going to drop in the box into the original output, and I'm going to drop in the points on there. And so ultimately it's going to create the structure here connecting all the points. All right, so if we were to go to and put this into the wireframe, we see, okay, this is how, notice that there are points in the middle, and they're all being connected, and they're all being serviced by the Voronoi fracture. Voronoi fracture, it's an n log n algorithm, so that means it's pretty fast as far as complicated algorithms are concerned, and it's very helpful, and it's a good exercise if you're ever feeling like can't fall asleep at night saying, man, I'm going to go and implement Voronoi fracturing inside of Houdini just because it's not. But let's take a look at what the outputs of these is. Notice that there are 2 outputs, and both of these outputs are very important. So on this first one, what we could do is put this into an explode SOP, and this will show how the object behaves as it's exploding. So notice here that it is exploded, and we can, as we adjust the uniform scale, we see kind of how the object is exploded. Now, believe it or not, this might seem random, but actually it's following a very, very specific pattern, and this actually has the telltale thumbprint of the Voronoi fracture in here. If you're not familiar with the Voronoi fracture, you begin to realize and begin to see this pattern in other scenes. So there are ways of getting around this, which is a whole nother modeling ambition, and we'll go into that kind of like overall a little bit later. Okay, so where we're going to go is we're going to go and click onto here, and then we showed that, and I'm going to go back to the Voronoi thing and show just where that is. And then I'm going to go into, and then I'm going to go into the selection node. Well, I'm going to put the display onto here, and then hit enter. And then I'm going to go in where it says select, and I'm going to go to 3D connect geometry, and I'll say group, and then I'm going to go to 3D connected geometry. Yep, that's what we do. And I'm going to select this corner piece here. I'm going to hit enter. I'm going to click that and hit enter, and then I've got that, and I'm going to throw in a blast node, which is going to isolate just this corner here. Okay, now we've isolated that particular blast, and what I want to do is click onto here. Oh, there's my blast. I want to put this off onto here, this explode view. I want to focus on this blast. And I'm going to delete all but the non-selected. And then we see this corner here. And then we see that this corner here, it exists as part of the overall geometry. You'll see that it is definitely in the corner here. And I'm going to go ahead, since we've got that on here. And so we see that it fits right into the corner. So what good is that? Well, I'll show you what good is that, because then I'm going to go in display output number 2. And then I'm going to put just a null here to act as a good anchor in order to which to visualize this. And I'll put the display on here. And notice that what we are looking at here are the actual glue constraints. And what are glue constraints? Glue constraints consist of nothing but 2 points. A constraint is nothing but 2 points. And if you notice, we turn that on here. If we hit the display and then turn this on there, you'll see that the point that gets is right in the middle of the Voronoi object here. And that was the original point that got created from the scatter stop. And you'll notice that for every chunk that comes away from the Voronoi, there is a center point right in the middle. And so what the glue is the center point of every single object, and a primitive is just one line connecting it. And if we take a look at the information, okay, viewers geometry spreadsheet. Okay, if we look onto here and we look, you'll see every one of these has got a name, and it's got a constraint, and you'll see that it is rest length. And so this is the initial distance between the 2 center points of these objects. And that's really all that a glue constraint is. It's nothing but the actual distance in between 2 chunks that are glued together. So that's interesting and useful to be aware of here. Okay, so we've got to get this. So I wanted to show you what all these. If we go ahead and turn on the entire network, I'm going to turn that on and then make sure to display this. And if we look into this into the wireframe, you'll see that this is kind of like, this looks like spaghetti mesh, but as you can see, these points are connected to all their adjacents. So we're going to prep this for output, and what we're going to do is we're going to make sure that we've got the exploded view. I'm going to lay down another null. Oops. And this null, I'm going to label this as out fractured wall. And this is just going to be the wall object. And I'm going to turn off the points there because we can see it good enough. And this is, we're going to set the display equal true onto that. And then I'm going to label this out underscore fractured constraints. Okay, so there's two things that we're going to take advantage of: the actual geometry itself and the constraints that are technically holding it together. Okay, we've got those ready to rock and roll. So let's go on up, and I'm going to lay down my DOP network. Oops. Nope, I don't want that. Okay, I'm going to call this wall destruction. All right, and then we're going to go and build this from the go for the ground up. Oh, and what I want to do is I want to turn off my fractured wall, so we're only going to be seeing what's inside of the wall itself. Okay, we're going to do this by hand because doing it by hand gives us a little bit more control than by going over into the rigid body thing and using all these macros. These macros are good, but they're really only good if you really understand what's going on. So I wanted to do this by hand in order to start demonstrating how these things are actually working for each other. And so the first thing that we're going to throw down here is a rigid body solver. Now notice that I'm using a rigid body solver. And this is very important because there's actually two critters that kind of look and sound a lot. The other one is if you do look for an RBD solver. Now you'll notice that the icons are practically the same. Now let's take a look at the parameters on these. So what's the big difference? The RBD solver is kind of like a more heavy-duty steroidal version of the RBD solver. The RBD solver gives you just the basics in which to manipulate all the parameters with, and it kind of exposes as kind of like a quick and dirty version. Now the full rigid body solver, though, this actually goes into the gory details and allows you to go into substeps here. Notice here we got substeps. What that does is it allows it to, a substep is, believe it or not, if it's going at 30 frames a second or 60 frames a second, a particle system or a dynamics measurement might be deformed actually more in between 2 frames, and it will look like the dynamics thing is actually pixelated, or it is kind of like jumping around. And going into the substeps will actually go in and solve for extra frames in between each of the individual frames. So we're going to get more and more high granular detail information, and it gives us more control. And so I'm going to get rid of my RBD solver because we have more control ultimately with the rigid body solver. And then I'm going to connect that to the output. And in between there, I'm going to drop in a gravity DOP because we're always going to end up with gravity. And it's going to give me an error there right now because, well, one, because we don't have any inputs on there. And we're going to solve that real quick. Now we're going to go ahead and then add the wall. And then we're going to get the wall, instead of using the macros up here, we're going to go and do this directly. And so I'm going to look for an RBD fractured object. Now mind you, this does not have any glue on it yet. So this is just a fractured object. And so I want to remind everyone that this is kind of like multiple objects being drawn in as one particular geometry object. So we've got this, and I'm going to call this my fractured wall. And then I want to send my path to the my fractured wall. I got fractured wall, and here's my out fractured wall. Okay, we've got that coming along here. And if we put the display, there's our fractured wall. And I'm going to put this into my solver. And we're still getting an error. What does that say? Connectivity to input is of the wrong type. Okay, so let's see what is going on here. Solve for on the created strike. Okay, let's see. It's connection to input 0. is of the wrong type. Okay, I'm not sure why that error is happening now, but if we go ahead and execute this, okay, we've got the RBD, we've got the bullet solver, and then the option, we go into here, the fractured wall. Oh, okay, we've got the output, the fractured wall, Voronoi fracture. Okay. All right, so I've obviously done something along here, off to a smashing start. Okay. And where is this kind of coming from? We've got the Voronoi fracture. All right, now there's some parameter here that I neglected to neglected to put. Now what would that be? Alta, no. Okay, and this is a fractured object. I wonder if we need to pack that. And okay, so I'm not sure exactly. RBD instance object, RBD fractured object. All right, I'm going to try to see what's going on here. So I'm going to click onto this and go into my wall destruction, see if I can kind of debug this myself. So I'm going to get rid of that. And then we still have connection is the wrong type. Okay, the rigid body solver. And so I'm going to go and see what the, and cheat a little bit and see what the macro would have done. So I'm going to go ahead and click this on here and click on my RBD fractured object. And so I'm going to click on RBD fractured object and click on this, hit enter, and then let's see what happens. And so we've got our fractured object that is going on, and it's not complaining. So I'm wondering what the difference was. We put our RBD fractured object on here, fractured by name. Okay, the SOP path. Maybe I put it as the incorrect path. Don't know. I put in the relative path, but I could be wrong. Okay, now if we go ahead and simulate this, and the thing falls through. All right, good. And does this add anything? So I want to get rid of this because we don't want that exactly yet. So it just added and threw in the DOP network. So that's not what we want here. And so I'm going to click onto here, and this is probably going to complain. And so I'm going to make sure DOP import, and I'm going to change this to out underscore fractured wall. Okay. Okay, I'm not sure what I did wrong, gang. Yep, there it is. It's behaving exactly as we did properly. I don't know, maybe you saw something I did do? I'm not quite sure. But anyway, here's the idea. I'm going to get rid of this merge because we don't quite need it yet. And so you see there is the exact same setup that I had before. All right, now we don't want the thing to be just flopping around and going through, and we could watch objects fall all day. But what we need to do is show some kind of interesting thing. So let's drop down a merge with the ground plane. So let's just drop in a ground plane object. No, that's not what we want. Gas upres, nice idea, but not yet. Give me a ground plane. And then I'm going to do is merge this with my gravity, pull that in here and put that into the output, and there we have our merge object. Okay, now let's go ahead and take a look at this. Now you'll see that as soon as I do the simulation, it starts to fall apart. And why is that? It's because this object is not glued. It has no glue to make it stick together. So gravity is going to naturally instill and then execute on this. And so what we have to do then is add a glue constraint to make this sucker stick together, because we want this thing to stick. We just don't want everything just falling apart. Ultimately, we want a simulation that is only going to fall apart until something happens, like the object falls or something collides with our object, and actually just start breaking these glue constraints. Okay, so I'm going to add a constraint network between the merge and the output here. And this is a constraint network. And this all pulls things together. Now notice that it has nothing to do with glue, and it's complaining again, not enough sources specified. Yes, we're going to go ahead and deal with that in a sec. But we're going to call this the glue network. And so I'm going to put the path to the fractured constraints here. Okay. All right, so I'm going to put in execute relative path, and then here is my object, and then fractured, and then we want the fractured constraints. Okay, now we have the actual constraints that are put in here. And now we actually have our glue network, but now let's actually give it the actual glue constraint itself, because this is our glue network. So let's grab the glue itself. So we're going to grab a glue constraint. It's a glue constraint relationship, and then we're going to drop that into there, and you'll see that the error goes away. And here we are dealing with the everything, and so the data name is there. Okay, gang, you know what I forgot to do? I knew this was going to be an error, so I am going to do. We have to, in order to prep this, we have to put some attributes to our glue in order to get it to behave properly. And so let's go back to our fractured object. So we have to add an attribute create. Now what we're going to do is we need to add something to every primitive, and we need to make it a string, and we're going to call this glue. And oh golly, you know what? I cannot remember. I'll give it a try once. But this name has to be something very specific, and I think the title for this has got to be constraint name. Now notice when we click onto here and take a look at our geometry spreadsheet, there's the constraint name, and every one of these names is glue. Now hopefully my memory is serving me correct. And so if we go up here and drop back into our null object, and what we're going to do is change the name here, and we're just going to type glue. All right, and so there is one telltale sign. If we go and see if we hook this up correctly, if we go into wireframe, hey, we hooked it up correctly. See all that red spaghetti mesh in here? That red spaghetti mesh is, you guessed it, this is the actual constraints. Now it's working because when we go into the glue options and we go into the color, we can now change the color to be whatever we want. And so if we want it to be like kind of mystical blue, we say, oh, okay, there's our glue constraints sitting right there, and this mystical blue stuff is there. I'm going to change this back to red because red just seems to be about the most. This magenta is really blaring. I'm going to try to stick with that. Okay, so we've got the glue constraints in there, so we can see that it's actually working and functionally. Now here is a little bit more information about how strong to make this. Here's the half-life of how long it takes to break apart this glue rate, and then here's the propagation information. Now the propagation number of iterations is how many iterations does it take for a impact to actually propagate through the entire volume and break all these glue chains. Now these are parameters that we can manipulate. Now you're probably asking, what are you talking about? I'm going to go over here to the smooth wired, and then we're going to hit play, and you'll see that the object now sticks together. That's because the glue is doing its good stuff. Now if we reduce the glue down to 0, now we can see that the object falls apart just as it did exactly before. And the amount of glue will tell us how much stickiness it's going to have. So if we make this 10,000, well, let's make this 1,000, then it might actually start falling apart again, just a lot slower. Why? It's because it's got glue information on it. So if we go ahead and take a look at this to kind of like ghost wireframe, this might be a little bit hard to see because of the wireframe, but as you know, as we start playing, you can actually see the glue constraints starting to fall apart, and they do so at an irregular basis. I'm going to go ahead and put this on real time, and so let's see if we can get this going a little bit slower. Maybe make the glue 500, and you can actually see the glue actually propagate up into the rest of the object. And so that's really fast. So what we're going to do, the propagation rate, I'm going to mark this as bait, and we'll see if it takes a little bit longer. Oh, so it's still very fast. Let's make it real slow and go for broke here. So you can actually start this. It's starting to get a little bit slower. And let's put the iterations here maybe to about 50. And yeah, it's still pretty slow. And let's see if we can get this slower yet. We'll put the strength at 1. Let's try to go ahead. And it's still real fast. And so here it is 0. And it's still falling apart. So I'm going to go ahead and see if we've got to revert these to default here, and revert this to default there, and the strength is 0. We go into here, and it's definitely still falling apart, albeit very slowly. All right. So we've got the glue constraints, and it's holding this thing together, over time. So let's actually add a collision to this to actually see what happens when we collide an object. Now, the whole purpose of the glue constraint is that a glue constraint is going to stay solid until there is a force acted upon it which is strong enough to break the glue constraint, and then it's going to move forward. And so and what we're going to do is it's going to stay in place until there's a force acted on it. So that's interesting, because the glue can actually be something that is coerced and parameterized. So what we're going to do is I'm going to go back up in here, and then I'm going to throw in a ball. So I'm going to add some more geometry, and I'm going to call this ball. Drop into here. And I'm going to call this, I'm going to drop in a sphere. Okay, I'm going to turn off all of this stuff for the time being. And then we have our sphere there. All right. And I'm going to turn this into a polygon, and I'm going to make this a frequency of 2, so it goes a little bit faster. And then I want to make sure that its radius sticks exactly above the ground plane. So as its center, I'm going to put in CH, kind of like what we did for the box, and we're just going to go rad Y, which is the radius Y. Now notice that we are not, I'm going to change the frequency over into 3. We are not going to do half of the value, because if we were to do half the radius, then that would be just the, it would just get it half of the way there, and it would still interpenetrate the floor. But if we do the full radius, that would be just about right. And so I'm going to append a transform to kind of move this ball off to the edge. We're going to give it a chance to roll in and speed into this. So we're going to knock that into 10, and it zoomed off, but have no fear, it's right there, ready to rock and roll into our system. And then I'm going to output a null. So null. Okay, I'm going to call this null and out for my ball. Out ball. Very good. Okay, I'm going to turn off this and then drop into my thing. And now I'm going to add my ball to the sim. Now the order on this is really important, because remember, we're dealing with a DOP network, and the DOP network actually goes from bottom to top and then left to right. And so the order is actually very important on this. And so in order to get this work, we're going to add a RBD, and not a fractured object, just a regular RBD object. Hello. And we're for the object name, the SOP path, I'm going to go // ball, and then out ball. Okay, some folks might be wondering, hey Chris, why are you always putting the ... on there? Okay, let me go ahead and get the display on it and see if there's our ball. And it is rocking and rolling and ready to boogie woogie. I always put the ... in there. It's because I like dealing with Houdini digital assets. And when you're working with Houdini digital assets, it's always very important to use relative pathing whenever you're using any kind of variable, any kind of channel, any kind of option. It's because the digital asset is a contained unit, and you want to stay within the contained unit. If you use the absolute world path, that absolute world path might very well change when you use that digital asset in another context of another scene. And so when you use things that are relative, then that means they stay in relative context to the digital asset environment itself, and it doesn't muck around. Okay, that's with and honestly, the ... / that's actually old-fashioned Unix for go up one level, go up another level, and then into the ball level. Okay, that's it in a nutshell. And so the input to the rigid body solver has to come in as one input. We can't put this and put this into here, because what it says, it's looking for the pre-solve, and this is also looking for the post-solve. No, that's not what we want. So here we have to go, all the objects have to come into there. And so in order to get these behaving properly, we have to merge all of our input objects together. Okay, now we see that we have all the objects sitting in together. And I'm going to go ahead and turn on my glue constraint. And for the strength, I'm going to move this to 1,000. And I'm going to put my display and my output so that we see everything. I'm going to go ahead and hit play. And nothing's going on. there's my wall. It's starting to fall apart. Oops. Come back, Johnny. If I was to put 100,000, yeah, this ball stays nice and still, but the ball isn't going anywhere. Why is that? It's because this is a simulation, folks, and just because we push it off to the side does not mean that it is working. So we have to give this ball some velocity. So let's go back into the rigid body object, and where it says velocity here, let's just give it some velocity here. So I'm going to put, no, we don't need that. Let's go with minus 20. We don't need that much velocity. Now let's see what happens. Okay, now look at the glue stayed fairly constrained, and it was very tight. Now if we were to go and look at this inside of the wireframe, you'll notice that some of the glue stays in contact and other places, and that's why these red lines are here, because those lines weren't propagated and so forth. Now if we wanted to go in and change things up a bit, then we could make sure we can run through this. So let's play around with this and turn this back onto the wireframe. And so if we wanted to change the propagation iterations, well, let's put with maybe 50 on here, and then propagation rate. Let's see what happens. Ah, look at that. If you have more iterations, then it's going to do more iterations through this, and it's going to break through. And so even though the strength is really good, it's still going to fire right on through. And so we're going to leave that rate at 1. If we wanted to go even slower, let's see if we go into that. So let's make this 0.01. I'm trying to capitalize on some of the speed here. And so that doesn't seem to have much of an effect. Let's see if we go ahead and add this, the propagation rate here, 1,000. And it doesn't seem to be changing much here, so that's something for me to continue focusing on into the future. Now, here it is. I'm futzing around with this simulation, and we could futz around with this all day. But the thing is, we've got two sources of force going on here. We have our glue force, we have the force of the ball hitting, and then we have the gravity, of course. And so there's too much stuff going on here for me to understand. And so therefore, I'm having troubles visualizing how much of this simulation is actually coming from the ball, how much of this is actually coming from the glue constraint, and how much is coming from gravity. And so in order to understand really what the simulation is doing, my suggestion is to go ahead and turn off all of your forces except one, and then add your forces in one at a time. Sculpt with forces, kind of like as if you were lighting a scene, if you're going to be sculpting with light. And so I'm going to go ahead and disengage the gravity, and then take a look and see what's going on here. Okay, so it is like really frickin' exploding here. And it is like, and gravity was actually playing a whole lot into this. So let's go and see if we can increase this glue a little bit and get the behavior. It'll be a little bit more like what we want here. Okay, and let's see the propagation iterations. Let's move this to 10. All right, look at that. The amount of iterations it took was a lot less, and things stayed a lot more chunky. Well, let's see if we go in between 20 here. Okay, so what I'm trying to do is visually I'm trying to create two pillars as they kind of break apart here. And so I think that if we had to go in with 15 here, Okay, so yeah, we see this definitely is breaking up into like two sides here. So we've got the strength in here, and I think it's at a good place. If we were to create, maybe make this 3 times more strong. How's that going to look? Okay, so it's obviously a little bit too strong, so that whole thing stays together. So let's maybe change this to about 1500, make it half as much. Okay, so we got those 2 big chunks going in here. Maybe it's a little bit too much. So let's leave that at 10 and then see what happens. Okay, so it kind of like breaks things apart. Now I think if we turn on gravity, now we're going to see the force of gravity added onto that. Okay, so it looks like gravity is a little bit too strong. It's holding things together a little bit too much, and it's making things feel that. So let's go ahead and now let's start working on the gravity. Now let's see, where it says negative 9.8 per meter second squared. Okay, we're allowed to futz with gravity here. So I'm just going to multiply this by 0.5. 0.5 times 9.8 meters a second squared. And maybe it's still a little bit too much. Maybe make a little bit less gravity yet. Okay, so it's busting through there. And it's still that. So let's break apart the glue just a little bit more. So we've got the gravity off to a good place. So let's go ahead and just make a smidgen more with the glue. Let's see if we change that to 50,000. Okay, still a little bit too much. Let's change that to 75. Okay, great. So I definitely want some kind of pillars going off to the side there. And so let's go ahead and we'll leave the gravity as it is. All right. And so we have gravity, and then we have everything ready to rock and roll. All right, so let's go ahead and export this now. We've got our simulation set up. We've got something that's set up that's pretty good. And we've got chunks coming through here. And we've got big chunks, we've got little chunks, we've got a variety of everything. All right, so let's go, and we've got the output here, which is great. All right, here is an interesting factor. Because I'm going to use VAT, or Houdini Vertex Animation Textures, to export this simulation, we're going to have to do some fancy nutting around here. And so what that means is that I'm going to try to export all of this as one particular object. And so we're going to go back over to my fractured object here. And so here we have the out-fractured wall, and I want to try to pull this stuff in to there, because this is the object that I want, and I want to bring in the ball as well. And everything is going to go okay. So I'm going to add a DOP import. Because notice here, when we play this, nothing happens. Well, that's because it's not piping in from the DOP network. So what we're going to do is grab a DOP import in order to import this from our DOP environment. And so our DOP network is ../../wall destruction. And we want the out of our wall destruction. There it is, output. Okay, there it is. Okay, notice that there's no ball in here yet. So we're just located in there, and that's because what we're doing is just transforming the current object based on the information that it's getting from the DOP network. If we want to get the ball included in here as well, then what we've got to do is fetch the geometry from the DOP network, and then we'll actually be dealing with everything that is dealing with on that. So if we click on here, and then we have everything kind of like going to get together. Now, this is all good and fun and exactly what we want, but honestly, I want the wall and I want the ball, but I don't want the floor. So the ground I could do without. And so here is on the object mask, I'm going to have to tell it what I want and what I don't want. And what are these names of these things? We go into the wall destruction and we notice that we have fractured, and we're going to call that fractured. I'm going to call this ball. And so we have ground plane. So this is called ground. I go back up in here and go into my fractured object. And so what we got here is I want inside, I want the ball and I want fractured. Okay, do I have to do this in the other direction? Okay, it is not the right name. Okay. Oh, okay. I am incorrect. It's not called that. The ball is, now we have the ball.
Okay, so maybe, so I don't know, like, operation, you want that as like a cinematic, that will be like,
And then if we return that, there's our ball.
okay.
And our ball
So there's not going to be another spirit that'll
is animated. Okay, now I've got the name incorrectly. So I'm going to have to go back into my DOP network and find out what the name is on this thing.
Okay.
And where am I going to find that? Okay, let's go into my geometry spreadsheet. And there's my ball, and there's my ground. But you'll see that instead of actually having the fractured wall coming in here, every one of the pieces inside of the wall, there should be 100 pieces, is represented by its own unique name. It's called piece 0 through piece 95. Okay, so there's 95 pieces in here. So that's the name that we should be using. I'm going to go back up into here, into my fractured object. And then so it's ball, and I go piece, and then star. All right, there, that's what we want here. All right, now we're talking. Now we've got exactly what we want. Now we're ready to go ahead and output this. And I'm going to call this, let's call this ball and wall. Ball wall. Out ball wall. Yeah, sure, why not? All right, we've got out ball wall coming at us, and that's good. All right, believe it or not, folks, we're not ready yet. Okay, what I'm doing here is a little trick that is used with that in order to create isolation here. Believe it or not, we need to create a bunch of materials to act as placeholders so that when we bring this into VAT, we have some way of differentiating all of the different objects. And so in that case, I'm going to come up here, and I know we don't see anything, so what I'm going to lay down here is a material network. And then I'm going to call this DOP mats for our destruction objects. They drop in here. And so I'm going to drop in a principled shader. Now, is that what I want? I do principled. Yeah, I don't want the shader core, I just want the principled. All right, cool. And now I want to go for the ball, and I'll call that, and I'm just going to color it red. All right, so that's going to be the the ball color. Now, believe it or not, our pieces or our wall is actually two objects. It's the interior and the exterior. We're probably going, what in goony goo goos are you talking about, dude? if we go back up into our fractured object, notice that when we come out of the Voronoi fracture here, we take a look into this, we are broken up into two groups. We've got the inside and the outside. The inside or the outside are those objects that are only on here. The inside are the geometry faces that are actually you can't see, and they're contained within the interior of the object. So we have two objects. Now that's one of the nice things that the Voronoi fracture does. Is it breaks it automatically into two groups, the inside and the outside. And so what we're going to do here is I'm just going to duplicate this. And then I'm going to go inside. And then we're going to make this green. And we're going to create one more for outside.
Yeah, I can rename this to be like.
And we're going to make that blue. Okay, we've got our ball, our inside and the outside. Technically, you can have as many different objects as you want going into a vertex animation texture output. The only difference is that the unique objects have to have their own unique colors. They have to have their own unique materials, because otherwise it won't know what's going on here. So I can go back in here. Let's go ahead and drop in. So we've got our fractured object here. So what I'm going to need to do here is we've got our exploded view on our blast. So let's drop in a material node. And push that in there. And we're going to create two materials. We go to the first one. We want to go to the group. We want the inside. And so for the material, I'm going to go in and grab the dot mats. And I want the inside. And then for our second object, we want the outside. And it's going to be the same dot mats. And we want the outside. Okay, now when we go ahead and display this, we see, hey, it's a blue object. It's a blue wall. Let's go ahead. And as it fires through, you can see that the inside faces are now green, with the exterior are now blue. Okay, so that's good, but we forgot to put in for the ball. And so we can't adjust the information here. So let's go back into the ball definition and then add our material here. All right, so I go group, and we want, so that is one thing we're going to have to do is put this into a group just to guarantee it. So I'm going to go and create a group for the ball. So it is, we know that it is just one big old group. And I'm going to group, and I'm just going to call this ball group. And so base group. No entries. I put in a star. Base group. Okay, geometry file, and then let me make sure I'm doing this correctly. So it all is into the ball group. Yes, all of our primitives are in the group ball. All right, now we're going to go in here. Now we've got there, so the group. This is the ball group, and our material is going to be dot mats. And we want the ball. All right. So we've got all of those hooked up. And so we got there. Okay, so let's go back up into our fractured object. And there is everything. We notice our ball is red, and we have our exterior, and then we see the interior once it's animated. All right. We are ready to rock and roll, folks. So I'm going to go ahead and save all this before anything bad happens. Save as. I'm kind of playing fire. It's been a while since I've done this. And I'm going to go, I'll call this demo
Joey was like, bro, that sounds
glue constraints.
because I wanted scattering sound.
All right, demo the glue constraints. We've got that going. All right, so let's lay down our ROP, which will hold our. I'm going to go ahead and click that on here so it's on. So I'm going to drop in my ROP. Okay, I'm just going to call this glue sim. I'll put that. I'm going to drop in a VAT.
I made the changes you requested last night.
Okay, it's got to go and think about this. And yeah, okay, so it's not too slow. All right, now, mind you, we're going to have to turn this on to rigid. And so rigid is going to be what we're going to be dealing with. And so our SOP path that we're going to be dealing with is .. refractured. And we want out ball wall. Is that right? Okay, so let's see if this is all right. Always second guessing myself.
They are, but like I also
Okay.
like didn't have enough time to like rewrite them. So.
And yep, this is right, out ball wall. Okay, so let's let it go for a full 300 frames. Yeah, that'll be fine. There's not a lot of information here. We're going to turn off the packed P scale into position alpha. And so here for our project F4, I'm going to export this, and then I'm going to call this demo glue, and then I'm going to call this glue constraints. Oh, I'll call this glue demo. Okay, we don't need position 2. Okay, we don't need the color. It might barf on us, and we don't need the scale because we're going to get everything animated there, and so we should be good to go with nothing but our position and our rotation. We'll go ahead and save this. So let's go ahead and execute this. Okay, it's still thinking.
It did not break on me. What happened?
And there we go. We are good to go. So let's go and check out our UE4 scene. And so let's go ahead and add a new folder in here. And I'm going to call this demo glue constraints.
Why does it randomly like die? I'm so confused.
Drop this in here. And so I'm going to go ahead and create a brand new level.
No.
Go grab a new level, default. And we should be good to go with this. Should be big enough. Well, let's make it just a little bit bigger. And I'm going to call this, 2 and 2. All right, that should be adequate enough. So let's go ahead and import our objects. And yep, take our EU. All right, we've got the Houdini Secrets. And then we go with the dynamics. We have export, and we're going to call this demo glue. Okay, so we've got the demo glue. We've got the glue demo mesh. Going to import into that. And so we're going to go in and we're going to make sure that this is replaced. I'm going to put down ignore. I could be wrong about this. I can't remember. I'm going to put ignore into that because we're dealing with rigid bodies. And we don't want to deal with the rigid colors. But otherwise, remove degenerates, we want that, and should it be import all. But in case this is a problem, I'm going to try to re-import this. Notice that when we imported it, it imported the 3 different materials. We've got the ball, the inside, and the outside. We're going to use that to our advantage in order to help kind of create separation, in order to pull all this in at one time. This is a really groovy technique, and you guys are going to like be amazed when you see this. Okay, I'm going to go into that, and here we have is all 3 that are on here. Now what we want to do is look for, it says use full precision UVs, we want to go ahead and click that on to be true, and then click Save. All right, now it says that it got it, but I don't know. UE4, it's awesome program, but it's dubious at sometimes. So I'm going to go ahead and exit it and then say, okay, would I like to apply the level of change to the detail? You go, yes. All right, but now you'll see that even though we've saved it twice, it still says it's not saved. So I'm going to go ahead and save it yet once again. All right, cool. So let's go ahead and then bring in our textures. And so if we go into textures, we have our position and our rotation. Okay, we've got those. So let's go ahead and turn these to colors into vectors. So I'll click on the first one, change the compression settings to vector displacement. Go ahead and go to the filter, change that to nearest. Save. And then go to the glue. Go to change it to vector displacement, the filter nearest. Click Save. Okay, we should be ready to rock and roll. Now, you'll see on other of my demonstrations, we actually created the material function that corresponds to the rigid body, but I'm not going to do that because I'm going to use the generic version. And UE4, isn't it clever? It actually comes with some stuff already built into it. It's like enough people are doing this, so let's put it into there by default. So I'm just going to go ahead and dive right into the material making aspect of it. So click on material, and I'm going to call this M underscore, we call this demo glue constraints. All right, click onto here. And as I said before, we don't have to go ahead because Side Effects and Epic have kind of teamed up and they said, okay, well, let's just implement some of this stuff. So I'm going to click on here and I'm just going to type in rigid. And if we'll see here, there's MF rigid body and it's under the Side Effects. Okay. So here we go. And now I'm going to cook up my normal and my world position offset. And you notice we don't have anything for the custom UVs, so I'm going to go ahead and click on this, and then UVs, going to go UVs, number of constraints, I'm going to change that to 3, and then I'm going to drop this into here, that's 1, and 2, oh yeah, there's one thing I want to do is get rid of the tangents here, so click on the tangents and make sure that the tangent space normals are turned off. All right, so we've got that going. So let's go ahead and add a scale vector. Not a scale vector, we want a vector, we want a scalar parameter. Got a scalar parameter, and we're going to call that speed. I'm going to drop that into here. All right, now we're going to get the position and the rotation. So we're going to grab those from our inputted textures. So we've got our position, we've got our rotation, drop that into here. Okay, this colorful one is going to be our rotation. And we got to make sure to turn this into a texture object. We're going to drop that into rotation. And now here, just to make sure, here's our position. I'm going to right click, turn that into a texture object. And then we're going to put this onto position texture. All right, there we go. I click save. And we've got the core structure already put into it. Oh yeah, here's something that we might want to do, and that's a little bit separate. We're bringing in 3 separate objects into our VAT simulation at the same time. So we're going to have to create 3 different materials for this. And I don't want to have to do this 3 different times. We're going to do this through creating multiple material instances. And so in order to do that, I'm going to expose a texture parameter, 2D, and then I'm going to call this texture. Okay, and we go to rigid body and click that into there. All right, now I'm going to hit save. And it's just picked up something random in here, and that's fine. Anything will do there because we're going to replace this with more interesting stuff. Now that we've created our material. Let's go and turn that into a material instance.
So what happens is that
And I'm just going to shift that
is
over.
very bad.
And we go mi underscore demo glue constraints. I'm going to drop into here. All right, so I'm going to expose my speed, expose my texture, number of frames, position min, position max, pivot min, pivot max. And we've got that going. And so let's make our preview mesh. Let's look for glue. Demo glue wall. Ooh. There we go. We have our ball and we have our demo glue wall. All right, so we're kind of okay yet, but let's go ahead and set these parameters according to the Houdini business. So I'm going to click onto here, and so we're at 299 frames, and that's the speed at 0.1 and all that gobbledygook. So I'm going to click on it here. We want 299 frames, and the speed is this. Okay. And now let's go back into Houdini, grab the position min, drop that in here. All right, so let's grab that into here. Oops, gotta go into Houdini, grab the position max, come back into here. Where's my position max? Drop that in there. All right, and then click on here. We want the pivot min. Click that to the pivot min. And we're going to click on to back in there and get the pivot max. And click onto there, get the pivot max. Okay, so this ball is kind of like flying around doing nutty things. You know what? I have a hunch we imported the object incorrectly. So I'm going to click Save and see if this changes anything. So I think I imported incorrectly. So I'm going to go ahead and click on this demo glue mesh, hit delete, and I'm going to force delete, and I'm going to get rid of the ball, the inside and the outside. Click on delete. Then I'm going to try to import this yet once again. Demon glue, the meshes, going into here. Click on the open. And then where it says ignore, I'm going to go with replace. Click import all. All right, then I'm going to go ahead and turn back on my full precision UVs. Click into that. Click onto that. Okay, we should be good to go. Is it turned on? Full precision UVs? Yes, save. Huh. It didn't know what it did the first time. And I was just like, okay, well, let's change and see how this. So let's go and drop into our material instance. And where is everything? Oh, here we're going to have to. We lost this, so I'm going to get rid of that. And so let's go ahead and reload it. Okay, so I think this, yeah, that's working, so it's colliding into there. But you'll notice that only the ball is animated. That is okay in this. That's because you'll see that this texture is the only thing that's affecting it. So I'm going to go ahead and change this texture to be something a little unique. Let's make it kind of like a, make it kind of bronze. Oh, give me some metal here. Okay, we have metal, rust, steel. Let's go with copper. Okay, so give it a good generic color here. I'm going to click Save. All right, so we've got our demo glue constraints And I'm going to change the name on here. So we call it demo glue constraints, but I'm going to call it demo GC underscore ball. And so what we got to do here is, since we have the inside and the outside, we have two more objects to focus on. So I'm going to go ahead and click onto here, and I'm going to duplicate this exact thing, and I'm going to change it from the ball to the inside, and I'm going to duplicate this again and make sure that this is the outside. All right, so let's go into the inside. All right, I'm going to change the inside. Then, okay, so let's see. How do we associate this material for? Okay, let's call this the. Let's go for the inside. Let's call this some kind of stone. And let's call this rough. Yeah, that's going to be the rough stone. And so now we have that. So that's rough. So I'm going to go ahead and save this. And then let's drop into the outside and call this stone itself. Not strawn, but we're going to call it stone. And let's go at hewn. So that is, no, let's go with cut clay and brick. Yeah, let's make a brick new. So give it kind of a red. So we've got red, pink, and smooth. So I'm going to go ahead and save this. Okay, the only thing left to do now is to go ahead and throw in our mesh. I'm going to make sure we go ahead and make this even bigger yet to give it more room to kind of flop around here. All right, now notice that we want 3 materials in here because we broke it up into 3 sections. So what we're going to do is, for the first one, we want the ball. So let's go on for a Dremel ball and throw that in there. And you'll see that it starts animating well enough alone, and it bops on through. Okay, so let's go and grab the inside, throw that into there, and there's our inside. And then let's go ahead and grab our outside and throw this into here. All right. Okay, so it's still not yet perfect, and I haven't really had a chance to really divest into figure out what's going on here. The timing works pretty well, and that's pretty good. It's a little bit slow. So what I'm going to do is, in my ball, in my glue constraints here, where it's the speed, I'm going to multiply the speed. I'm going to create another vector. Well, no, I'm going to leave that as is. I'm going to create a constant. And then I'm going to put this in for, make it twice as fast. And so I'm going to multiply these two together. So whatever the speed is, it's going to come through here, the speed, and I'll hit save. Okay, now things are going a lot faster in here, and it makes it a little less boring. Okay, now we're still getting a little bit of an alignment issue, and honestly, I think this is because we have a lot of information here, and it is not being incorporated for. What I think, in order to fix this, I have 2 solutions. One is to export, do a VAT simulation for the ball, and then do a VAT simulation for the inside and the outside of the wall. That is one solution, bring this in as 2 objects. Or what we could do is, because there's a lot of detail here for the ball and the collision of the wall, And I think we're dealing with a precision object. And so what we would have to do is we don't have enough time to kind of deal with this, but in Houdini, if we put this to a pad to a power or double textures, if we do the double textures, we would get higher precision. And I believe that this would actually go ahead and fix that problem. And so that would basically fix this and get this going. And I think that it would do. Of course, what we'd have to do is turn this on and turn on this position, and we'd have to bring in a whole brand new texture. Now, when we bring in this whole brand new texture, we would bring in here one new texture, and it would go right into here. And the additional thing that we'd have to check is then on each of these, the other thing, we'd have to turn on this feature as well. And I believe if we do that for all three of these materials, everything will line up and look proper. All right, cool. So everything is working pretty much as we said, and we now have a better understanding of how we're going to do our glue constraints, what the purpose of glue constraints are, and we know better now how to deal with the networks associated with forces. Because that's one thing that I didn't really have a very good understanding. Is okay, we've got these networks. How are we going to put them all together? And so these glue or these various networks glue the forces, and these forces, the actual relationships, allow us to fine-tune and noodle with the actual forces. So I'm going to have to remember that and use this for the other forces that we applied onto our scene. All right. So let's go ahead and wrap this up. Okay, I'm going to go ahead and boogie woogie and wrap this up here. And yeah, I don't want this. And so I'm going to boogie all the way on through this to the entire bit of my lecture here. All right. Now, what we did was cool with this, but honestly, I have to admit, I'm getting kind of frustrated, gang. So I thought I was going to, for 5/7, that's May 7th, what I thought I was going to do is go about rigid body dynamic collisions. Okay, John Moncrief at Side Effects has put out a whole brand new tutorial on that. And so I'm really interested in saying, okay, what am I not figuring about at the essence of collisions that I'm not quite getting? And I think I have a pretty good understanding of them, but it couldn't help to go through this. So I was planning on giving a synopsis of that lecture, but instead, you'll notice that we are spending a lot of time putting our VAT simulation into UE4 and going through all the same nutting business of loading in the objects, loading in the textures, offsetting the parameters for our objects, offsetting the textures for our parameters, and then setting up all the individuals. What if we had a way of automating that entire process? That would speed things up a whole lot. And so what I'm going to do next week, I've decided and changed my mind. I love serendipity. I am going to show you folks how to create a way of automating this in Python, so that all we have to do is just run a little Python script, tell us the name of the simulation, and it's going to pick up this automatically. And so that's going to make things a lot faster, and it's going to make things a lot easier. And you know, this is the tech artist in me. I'm always going to want to try to start speeding things up. So that's what we're going to do next week. We're going to show how to speed up and automate VAT. All right. Now, if you liked what you saw today, go ahead and subscribe to this broadcast. Go ahead and click on that little icon down in the lower left-hand screen of the YouTube screen. Go ahead and click that. Or if you want to, go ahead, check me out. My name is Chris Rhoda. Check me out on Facebook and on LinkedIn, or go to TechArt.edu and check out TechArt.edu on Facebook and on LinkedIn. And if you really want to help me, drop on down to the TechArtEDU.com website and opt in to our website and give us your name and your email address, and we'll make sure that you get updated to the latest articles and the latest goings ons with everything that is going on with TechArt EDU. Now, things are a little bit slow right now because I'm focusing big time on getting real-time visual effects for the technical artists out the door. As soon as we get back then, we should get back on stream and we should start really moving along very quickly. Thank you all for your patience, folks. I appreciate your patronage. Thank you very much. And I look forward to working with you again next week when we work on automating the VAT process. So until then, arrivederci.